So in study unit 4, you are introduced to the gain margin and the phase margin. The gain margin and the phase margin help you to determine the stability of an amplifier. If you remember from study unit 1, whenever you add a pole, there's a 90-degree phase shift. So if there are more than 2 poles in a system, there's a chance that your system may be unstable. So to determine your gain margin, you find the point where your phase crosses 180 degrees, and you find that point in omega or in frequency, depending on how your graph is drawn. Then you measure this amplitude, and then your gain margin is 0 minus the amplitude that you have gotten here at that value of 180 degrees. And then for your phase margin, you go down to where your graph or your Bode plot, you go down to where this Bode plot crosses 0 dBs, and then you track down the value and you read your phase margin here, and then you have 180 plus this value, and that's how you calculate your phase margin. For your amplifier to become stable, to be considered stable, your gain margin must be positive and your phase margin must be positive. So sometimes we are given amplifiers that are not stable. So therefore, we need to stabilize them by either decreasing the gain of the system or by adding a new dominant pole to the system, right? So the way you do that is like this, right? So if you have this system here with these 3 poles, and it creates this graph there, where this is the first pole, that's the second, and that's the third. You can increase the phase margin and the gain margin by decreasing If we are presented with an op-amp that is unstable, there are 2 methods in which we can stabilize the amplifier. We can stabilize the amplifier by either decreasing the loop gain or by introducing a dominant pole. To explain these concepts, we will consider this transfer function right here. It has 3 poles, 10 to the power 5, 10 to the power 6, and 10 to the power 7. And because it has more than 2 poles, there is a chance that it is unstable. So the loop gain, the magnitude plot is drawn here in gray, and the phase is drawn down here. So when we look here at our unity angle, our unity frequency, we can see that here our phase margin is negative. And when we look at our 180 degree, which is right about here, right about there, we track it all the way up to see that our gain margin, which is between there and there, our gain margin is also negative. So now the first way we can increase stability is that we can decrease the loop gain. You see, we take this graph and we literally move it down, right? We move it down like that. So we move it down to a point where we have a positive phase margin and a positive gain margin. When we move it down to this black line that is shown here, right there, right? We can see that here at our unity frequency, we've got a positive phase margin, and at our 180 degree, we've also got a positive phase margin as shown here, right? So, a positive gain margin. So the second way in which we can make our system more stable is by introducing our dominant pole, right? So imagine for a moment that this line that I'm drawing right now is the system that we have described, right? By adding a dominant pole at this position, right here, we can make it cut off earlier there. We can therefore increase our phase margin and increase the gain margin, because of this new pole here that we have introduced, our system behaves differently. We've got a different a different 3 dB cutoff point, because the pole that we introduced is dominant, and it will dominate the amplifier characteristics.